Hi, class. This is Mr. Hart. On this podcast, I want to go over our unit on the periodic table and chemical bonding that we're going to start. Before we can talk anything about the periodic table, though, we need to first kind of review what we know about atoms. Okay, and hopefully, from a previous science class, you've learned about the charges of each particle. You know, a proton has a positive charge, a neutron has a neutral charge or zero charge, and an electron has a negative charge. Okay, so we have these three parts of the atom, and they all are in different locations. The protons and neutrons are in the nucleus of the atom or the center, while the electrons go around the outside. And so hopefully you have a basic understanding of this idea of what an atom is. Okay, but we want to look at how elements are formed from atoms and what determines what type of element an atom is going to be. And so we have this key idea that any element is determined by the number of protons in that atom. Okay? So elements are determined by the number of protons in the atom. Okay, for example, helium atoms will always have two protons. Okay, so if you have an atom, doesn't matter how many neutrons it has, doesn't matter how many electrons it has has two protons, it's going to be a helium atom. Okay, so no matter what the element, you can look at the protons and determine which element it's going to be. Okay, and so the periodic table is just really a list of all these different elements based on the atoms that form them, these protons and neutrons and electrons. Okay, so let's say we look at a single square in this periodic table. Okay, let's look at xenon, for example. If we look at an individual square, okay, the two letters or one letter in the center is called the chemical symbol. This is how we represent the atom whenever we're doing chemistry or any type of chemical reaction. Okay, this is the actual name. Okay, if we need to use it in our communication, I can say this is a xenon element or xenon atom. Okay, but the biggest part is this number right here. Okay, the most important part is this number right here. This is called the atomic number. Okay, and the atomic number is really just the number of protons in that element. So if we look right here on any of these boxes, we can figure out that that's the number of protons. So in xenon, for example, there are 54 protons. Okay. Then this number down here we call the atomic mass, which is the number of protons and neutrons combined. Okay. This has a decimal because it's an average. Sometimes you have more or less neutrons in there. But on average, I have about 131 protons and neutrons in a xenon atom. Okay, so we have these two definitions, and make sure you write these down. So we have the atomic number, the number of protons in an atom, and the atomic mass, the number of protons and neutrons in an atom, okay, or element. All right, so if you look at the periodic table, you can determine those features just by looking at the individual squares in the periodic table. Okay, but now we want to talk about the man who discovered the periodic table, Dmitry Mendeleev. So he was a Russian-born scientist. In particular, he was in Siberia, a very cold part of Russia. Okay, and he had kind of a sad early life, sad childhood. His father died when he was very young. His mom tried to make a living for him, but she had a factory and it burnt down. She tried to take Dmitry to Moscow University on horseback. She rode 400 miles. They rejected him there. Okay, and so all this time, his mother was trying to get Dmitry to some type of university because she knew he had potential. So eventually, she rides 400 miles when Dmitry Mendeleev is 12 years old to St. Petersburg University, and they finally accept him there. But then about a year later, uh, his mom dies, and Dmitry is an orphan at 13 years old. Okay, but he still is at St. Petersburg University, and this ends up leading to his discoveries in chemistry and such. Okay, so the main thing is that Dmitry Mendeleev discovered what's known as the periodicity in elements. Basically, he realized there was patterns that you could follow between each elements, that these elements had repeating characteristics. Okay, so he's the one that set up the periodic table. And it was interesting. There's a story of a man coming in, a French man coming in saying, "Hey, I discovered a new element, and it has its properties." And Dmitri Mendeleev said, "No, it doesn't, because according to my periodic table, it should have these properties." And he was actually right. Mendeleev was right, because the periodic table was so well organized that he could predict what elements would be like once we discovered them. He could find the missing spots in the periodic table and guess what those characteristics would be like. So very interesting, and really quite amazing how well it predicted these elements. Okay, so then we looked at the different parts of the periodic table. Okay, this column right here is called the alkali metals. They're very reactive very reactive substances. Most of them react with water. Okay, so just you don't see a lot of them in nature because they just react right away. Okay, then we have the alkaline earth metals. These are kind of more common, you could say. Things like calcium, magnesium, some of these things you kind of would find in food and stuff, but not quite as reactive as the alkali metals. It's still a very interesting group. Then we have the transition metals in the center. Okay, these are what you would think of as normal metals, things like cobalt, nickel, copper, silver, gold. Okay, any type of metal, when you think of metal in your mind, kind of the intuitive definition of metal, they go under transition metals. These things are good conductors, but not very reactive. Okay, then this section over here is kind of a weird combination of what we call metalloids and metals and gases. Okay, so we don't give it a specific name. But then we have this column right here, which we call the halogens. Okay, also very reactive substances. These are gases. Okay, very reactive. They like to react with these guys over here. Okay, you probably have heard of sodium, Na, chloride, right, Cl. And so this is a combination of an alkali metal and a halogen. Okay, so halogens, very reactive gases. And the last column we'll talk about is the noble gases. They are not reactive at all. Okay, they kind of have the name noble because you can think of a nobleman who doesn't interact with the peasants, you could say. So the noble gases, very unreactive, but very stable. Okay. All right, so those are the different parts that you should know. We won't worry about these two down here, the lactonides and the actinides. Okay, just worry about those five I covered. Okay, so the alkali metals, alkaline earth metals, the transition metals, the halogens, and the noble gases. Okay. All right. So moving on. So one of the things the periodic table tells us is how to find the number of protons and how to find the number of neutrons. We can find the protons from the atomic number, right? That's written. We can find the neutrons from minusing the atomic mass minusing the atomic number from the atomic mass. But it doesn't specifically say anything about electrons. Okay, so we have this other key idea. Okay, that the number of protons in a regular element is the same as the number of electrons. So for any element, I can figure out how many protons, how many neutrons, and how many electrons I should have. Okay, so for example, let's say I have something with an atomic mass, okay, or sometimes written as a mass number. Okay, a mass number. Let's say it has a mass number of 23. Okay, and let's say it has an atomic number of, let's say 12. Okay, it has an atomic number of 12. Okay, so mass number 12, atomic number 12. Okay, we can find the number of protons pretty simply, right? Because it's just the atomic number, 12. Okay. We can find the number of neutrons by minusing the mass number and the atomic number. So 23 minus 12, that's going to give us 11. Okay. And then the electrons is just going to be the same as the protons. So 12. Okay, so just by using this number, the mass number, and the atomic number over here, I can determine the number of protons, number of neutrons, number of electrons. Okay, so this is really nice for the periodic table because looking at any element, we can determine all these features about it. Okay, So you should be able to do that with any element given on the periodic table. All right. So the next thing we talked about is what we call an electron shell diagram. Okay. So an electron shell diagram is a way to look at where the electrons are going to be placed around an atom. Okay, so you may have never heard of shells. Maybe you just thought there was one orbit that all the electrons went around in, but there's actually distinctive groups, distinctive levels that these electrons can orbit. And it turns out that only a certain number of electrons can fit in each one of these levels. Okay, so the electron shell diagrams helps us visualize this. So this is how you would draw an electron shell diagram. Okay, so you always start with the innermost level, and you put electrons on that level until it has no more space, and then you move to the next available level, and then you put electrons until that has no more space, and then you move to the next available level. Okay? And so we'll do an example in a second, but you'll want to remember these numbers. Okay, the first level can only have 2 electrons. The second level can only have 8 electrons. The third level can only have 8 electrons, and the fourth level can only have 18 electrons. And we won't go past that. After that, it gets a little bit more complicated, but we'll just worry about the first 4 levels. So for example, let's say we're looking at this electron shell diagram, and we want to do 12 electrons. Okay, we want to fit 12 electrons. So if we want to do this, we need to figure out which shells can hold which number of electrons. So if you remember, we start at the innermost shell, okay, and we put in electrons. Okay, so here's 1, here's 2, okay. The first level, if you remember, can only fit 2 electrons, so we have to go to the next shell, the next level. Okay, so we can't fit any more on this orbit, so we go to this one. So then we go 3, 4, 5, 6, 7, 8, 9, 10, okay. But now you'll see we have 1, 2, 3, 4, 5, 6, 7, 8. There's only 8 we can fit on the second level, okay? And so then we have to go to the third level. So the third one, we go 11, 12. Okay, we're done. So this would be a very rough sketch of our electron shell diagram. Okay, so there's 2 on the innermost, 8 on the second level, and then 2 on the third level. Okay, so that's the process we use to draw the electron shell diagrams. Okay, hopefully that makes sense. Let's just look at another example. Okay, here's a potassium shell diagram. So potassium, if you look at the periodic table, it has 19 protons and also 19 electrons. So the first shell fits 2, the second shell fits 8, the third shell fits 8, which is a total of 18, and then the last one, the 19th one, goes on the 4th level. Okay? So hopefully this is making sense. As you practice more, I think it will start to come to you, hopefully. But we want to cover one more term with the electron shell diagram, and that's the idea of a valence electron. Okay, so a valence electron is the number of electrons on the outer shell of an atom. Okay, valence electron is the number of electrons on the outer shell of an atom. So if you look at potassium, on the outermost shell, it only has 1 electron on there. So potassium has 1 valence electron. Okay, in our carbon-12 example we had 2 electrons here, so that would have 2 valence electrons. Okay, so valence electrons, just the number of electrons on an outer shell of an atom. Okay. All right, so I know that's a lot of new terminology, but go back through and kind of get a good feel. Try and practice a couple of examples to see if you're really getting down to the shell diagrams, how to calculate the protons, neutrons, and electrons. Okay, and then also make sure you do the homework assignment, the atom board sheet. Okay, I believe it's called on the website, and that's just a lot of examples of calculating the protons, the neutrons, the electrons, and the electron shell diagrams. Okay, so hopefully that made sense. Let me know if you have any questions, and thank you for watching.